Hello, we are going to continue part C of question 3. In this question, we wanted to show the identification, we derived the moment conditions, and we would like to show that the original parameters are identified, and if needed, state additional conditions. Okay, pretty standard uh, standard argument, right? So I'm going to show you two different ways to identify the problem. But the ideas are the same, but one is more convenient. So first, the moment conditions we had are these. Expectation of yi minus alpha 0 minus beta 0, li minus gamma 0, hi equals 0. This is about intercept, right? About the constant term is multiplied with constant term is 0, and yi minus alpha 0 minus beta 0, li minus gamma 0, hi is 0. This is uncorrelated with L. And finally, we use gi as another moment condition. Okay, so these three moment conditions are used to identify three parameters. Okay, so we use three parameters, and for simplicity, I'm going to define theta as a vector of parameters, alpha, beta, gamma. And let's define x, which is a vector of regressors, and z as instruments, 1, L, gi. Okay, so then it is standard. Here it's the first one has a hidden constant term. 1 is multiplied because we include intercept, and then because g, usually we denote the moment condition as g, but it is used here, so I'm going to define mi, moment condition, moment function as mi, which is zi times yi minus xi transpose theta. This is the moment condition, and we know expectation mi theta 0 at the true value is 0. So these three conditions can be summarized into this notation. Okay, so it is I. And then from there, it is a very standard form. Like if we rewrite, this is very standard form. So you may rewrite this as the moment conditions as ziyi minus expectation zixi transpose theta 0 equals to 0. This is the moment condition, which is linear in the parameter, right? So it satisfies the form of like say, a times theta equals b, right? And then theta equals a inverse b if a inverse exists. This is basically the identification argument. We are going to use this. And then in this format, we can rewrite this as this. Here, let's check the dimension. Z is 3 by 1 and y is 1 by 1. Z is 3 by 1, x transposition is 1 by 3, and theta is 3 by 1. So dimension matches. So of course then 0 stands for a 3 by 1 vector of zeros. So this is exactly same form of this one, right? We only need to check its invariability, right? It is square matrix. Maybe okay. So let me generalize it. So this is when it exists, but usually when we say then theta 0 is unique if rank of A equals dimension of theta. So this was more general setup when A is not square matrix. Okay, anyhow, in this case, it is square matrix, so we don't need to worry about the other thing, the more general case, right? We have exact identification, and then what you need is the additional condition is its invariability. If you expand, replace z and x using this definition, and then you can write it as Li expectation Hi expectation Li expectation Li squared expectation Li Hi expectation Gi expectation Li Gi expectation Hi Gi. So this is a 3 by 3 matrix, and you have to show that it is invariable, which means its determinant is not 0. Basically, it's the same thing, which means it's invariable and it is non-singular, right? Basically, all those things are equivalent statements in mathematics. But the problem is 3 by 3 matrix, it's not easy to derive the determinant and to check its invariability. So then what I recommend is, what I have been recommending and what I taught in classes, we are going to drop, we are going to drop the intercept alpha 0 by demeaning. So these days, I'm reading some like machine learning papers, and in the machine learning papers, so demeaning, they call demeaning as centered data. Basically the same thing. They center all the data without saying that. They implicitly assuming all the data have mean 0, right? I was pretty. It's a different standard is used there, but we can adopt. So demeaning is not something strange or bad, right? So remember, we defined L tilde, G tilde, and Y tilde, like K tilde, like H tilde, and all the tildes, and then we have Yi tilde equals beta 0 Li tilde plus, like say, gamma 0 K tilde plus epsilon I, something like this. We dropped the intercept. Intercept does not exist anymore because everything has mean 0. And then instead, in this case, then now we only have 2 parameters. So as a result, we only need 2 moment conditions. That is expectation of Li tilde, Yi tilde minus beta 0 Li tilde minus gamma 0 Hi tilde equals 0, and Gi tilde Yi tilde minus beta 0 Li tilde gamma 0 Hi tilde. So we only have these 2 moment conditions. In the previous moment condition, the first one disappears because it uses the constant term as the instrument, but the purpose of doing this centering, this demeaning, is to remove all the constant terms, so it disappears, right? And we only need these 2 conditions, and they are mathematically equivalent, right? Mathematically equivalent. We just cancel out one unknown by dropping one equation, right? So, and then again, in this case, you can define, say, theta tilde as only beta and gamma, and x tilde only as L tilde and H tilde, and Z tilde is, say, L tilde and G tilde. Everything is the same, but we just drop the constant term and the intercept. Okay, so the moment condition, the new moment condition can be written as Zi tilde Yi minus Xi tilde transpose theta tilde, theta 0 tilde equals 0. Again, let's check the dimension. Z tilde is 2 by 1, Y is 1 by 1, X tilde is 2 by 1, but after transposition it's 1 by 2, It's 2 by 1. So the dimension matches. 0 should be 2 by 1 vector. Okay. And then again, we just need to show for identification, we need the condition that zi tilde times xi tilde transpose must be invertible. That is the identification condition. This is the identification condition, right? And it is simpler because it is 2 by 2. So this is expectation Li tilde square, expectation Li tilde and H tilde, expectation Gi tilde Li tilde, and expectation Gi tilde Hi tilde. It's 2 by 2. So for this to be invertible, we need assume that expectation L, its determinant can be written as AD minus BC. That's how I memorized it. Like, right? You know how to. This is the determinant. Determinant should not be 0. That is the condition for this matrix to be invertible. And one more thing. So remember, this is basically variance of Li, right? And this is covariance of Gi and Li. And this is covariance of Li and Hi. And this is covariance of Gi, Hi. Okay, so we are not doing something very strange. All of these guys are natural interpretation. And also we did this in homework 1. What you did in homework 1 is basically this idea. Okay, so this is a solution to the identification part C. So in the next video, I'm going to do the other part, the implementation of GMM and asymptotic variance of GMM. Okay, thanks for watching. See you later.